Greetings, calculus fans. All right, so this is day one of chapter 2 in calculus, and basically the title of this chapter is limits. We're going to use some of the graphs that you guys were supposed to do for homework the day before. You had 6 functions you had to graph, and so we're going to be using that. So anyway, let's move on here. I'm just going to highlight some things because you should have this kind of in front of you, math fans. And again, this is limits of a function. All right, and it says consider the function. So I'm going to read some of this, whatever you want to do. Just the main part of the notes is coming up here with the graphs and everything, but this is just some basic things. It says consider the function y equals f of x with an infinite number of ordered pairs in this function. As x changes, y changes, of course, right? That's kind of how a function works. If I chose a collection of x values very, very close to a certain number, and I even said, suppose that x approaches a number c, and then record the accompanying y values. So that's kind of what we're looking at. We're saying, hey, when x gets close to some number, what's happening with y? And it even says here, y values are also observed to be approaching a particular number, and we'll call this number L. All right. So we keep moving down here. It says the number L that the y values are approaching as x values are approaching c is referred to as the limit of y equals f of x as x approaches c. So this is really key right here, math fans, right there. Okay, it's the limit as x approaches c. So x is approaching a number, and you're saying now what is y approaching? Y is approaching that L value. So it even says it reads as the limit of f of x as x approaches c is L. Okay, that's what this little friendly guy right here is, as x approaches c. Okay, and it says next here, it needs to be noted that the x value in question, x equals c, can be approached from either the left side or the right side or from both sides. This is actually super important. It's either the left side, the right side, or from both sides. Okay, approaching x equals c from the left side, this is how you write that. Okay, I'm going to highlight this guy here. See that little negative sign there? X approaches c from the negative side. That means it's coming from the left, which makes sense. More negative, think of a number line coming from the left. That's why you have it. That's what that means, approaching from the left side. And that may yield a different limit on the y value than if we were approaching x from c from the right side. And see this little plus sign right here? That means we're coming from the right side, so from the positive side. Okay, it's very important. When you see that, this guy right here, from the negative side or from the positive side, these are called one-sided limits. Very, very important. If you don't see any sign, okay, like there's no sign, this is just x approaches c, that's called a two-sided limit. Okay, that's important. A one-sided limit, you see that sign, the plus or the minus, and if there's no sign there, that is called a two-sided limit. Okay, so this is theorem 3 on page 64 in your calculus book. Basically, if the limit as x approaches c from the left-hand side, from the negative side, right, from the left side, is equal to the limit from the right side, okay, then the two-sided limit is equal to that same value. So if both of these are true, and they equal a value, okay, they equal one value, a certain value, then the two-sided limit also equals that value. All right, and I could just rewrite the second line is just reversed of that. If I told you the two-sided limit is equal to a value, then you could say, oh, that means the left-hand limit and the right-hand limit are equal to that value. Okay, this next thing is huge. Huge. If the one-sided limits are not equal, then the two-sided limit does not exist. That's really important. Okay, if one-sided limits are not equal, then the two-sided limit does not exist. All right, and then here's just other couple things here. For formal definition of a limit, you can see top of page 60, and also this is just something to look over too. Be familiar with some of these different theorems. All right, so that's it's pretty important stuff here. Talking about just to get a basic understanding of what limits are, one-sided and two-sided limits. All right, so let's look at some of our graphs here, and then I do have a few more comments after we're done with our graphs, which is not on this note sheet here, but something definitely we have to discuss. All right. All right, so here are our graphs. I actually have them all graphed nicely for you. It's an absolute value graph. This is important here, math fans, and it's even highlighted and it's bold. It says below you find the graphs that you're completed for today. Use the graphs to find the requested limits. Remember, limits are about approach. Limit means I'm getting close to it, but I am not there. That is so important. Function values, and when I say a function value, that's like saying f of x, f of some value. Okay, that means I am there. Okay, so function values are about arrival. Limits mean I'm getting closer and closer and closer. I'm not there yet. Function values, I'm there. Okay, very, very important. All right, so let's start out here with some of these problems. Okay, so right off the bat, see that A? A says f of 2. What does that mean? It means I am there. Okay, that's important. I'm there. So that means I plug in a 2 into the equation. Okay, the absolute value, it's 2 minus 2 is 0. The absolute value is 0, 0. So f of 2 is 0. Okay, now let's look at it. What happens is I'm coming from the left side. That's what that x approaches to from the negative side. I'm coming from the left side, which is here. Okay, what is my y value approaching? Don't you guys agree? I'm approaching 0. Okay, right? It happens that it's a closed dot here, which you're going to see the next example is an open dot, but I'm approaching that value, so that means my answer for that problem is 0. I'm approaching 0 from the left side. Well, what's going on from the right side? Don't you agree I'm also approaching 0? Okay, so both of those answers are 0. Well, as you learned just in that previous page, if the left hand and the right hand limit are the same, then the two-sided limit is automatically that number. Okay, very important. All right, so let's look at limit as x approaches 3. Okay, that's this point right here. X is approaching 3. What is that? It's a two-sided limit. So what's going on as I approach it from the left side and from the right side? Well, isn't the y, because remember we're looking at the y value, isn't the y value 1? Okay, right? Does that make sense? And just out of curiosity, what is f of 3? Well, isn't it also 1? So this one is, in this case here, the left hand, the right hand, the two-sided limits, and the actual function, okay, they're all the same. So let's look at the next value here. It's very similar to the last problem, except I even tell you it's a piecewise function. I tell you it's undefined at x equals 0. Defined everywhere else. So now I'm saying, what is f of 0? Well, what f of 0, isn't that undefined? Because it even says at x equals 0 it's undefined. Now let's look at the limit as you approach it from the left-hand side. What am I approaching? What y value am I approaching? I'm approaching y equals 0. Do you guys agree with that? Remember, I'm not there yet. I'm getting closer and closer and closer to it. I'm not at that hole. I'm approaching it. So my answer to the first one is 0. What about from the other side? What's going on? Okay, well, if I'm coming from the positive side, aren't I also approaching 0? Okay, if I said I was there, it'd be undefined, but I'm not there. I'm getting closer to it. So it's getting, if I get closer and closer, it's 0.01, 0.001, 0.00. So what am I getting closer and closer to? I'm getting closer to 0. So what is my two-sided limit? Well, again, these are the same. So it's 0. Okay, let's look at x equals 2. Well, isn't 2 right here? And it's a two-sided limit. So what is it getting closer? This way and this way. Okay, happens that the one-sided limits are the same, so I'm getting closer and closer to the value of 2. Now this function that you graphed, this has a hole in it. Okay, because if I had factored that top, I'd get x plus 3, x minus 3. The x plus 3's cancel, and I wind up just getting an f. My function is x minus 3. So I do have a hole right here. That's actually an important part of limits. If I said, what's f of negative 3? Don't you guys agree that's undefined? Okay, because it's not defined there. It's a hole there. Okay, what about if I approach negative 3 from the negative side? Okay, what's the y value? Isn't the y value negative 6? Right? Because again, it's the x is approaching negative 3 from the negative side. So that y value is negative 6. I'll put it in red, doesn't matter. Okay, what about from the positive side? Negative 3 from the positive side. It looks confusing, right? It says x approaches negative 3 plus, but remember that plus on top means coming from the positive side. So I'm coming from this side. What's it approaching? Well, it's also approaching negative 6. So what's the two-side limit? Negative 6. What about as x approaches 0? Okay, well, again, there's 0, and it's approaching it. Is there any hole to even worry about? No. So my two-side limits are the same. They're both negative 3. Or my one-side limits are the same, so this answer is negative 3. What if I said, what's f of 0? Well, don't you guys agree? F of 0, again, I'm there. That's cool. It's a closed dot, so f of 0 is negative 3. Okay? All right, let's keep going here. All right, number 4. This is, again, another nice little piecewise function. Okay, and what is f of 4? Well, it's not by this closed dot, or by the open dot, it's by the closed dot. So f of 4 is right there, and so that value is 5. What about coming from the left hand? Now this is where it's a little tricky. We're coming from the left hand side. Okay, so that means I'm coming from this side here, and what am I approaching? Again, see I have a hole there? I don't really care about the hole. The hole doesn't matter with limits because I'm never going to get to the hole. I'm only approaching it. So if I'm getting closer and closer and closer to that, what's my y value? Well, isn't my y value going to be negative 5? And let's approach 4 from the positive side. Well, here it is. I'm approaching 4 from the positive side. What is that getting closer and closer and closer to? It's getting closer and closer and closer to 5. Right? Again, that's your y value. What's getting closer to 5? All right? And so the question is now, what is the two-side limit? Well, the two-side limit, because one is negative 5 and one's positive 5, they're not equal, so this does not exist. Very important. D and E, do not eat. Okay? All right, let's look at number 5. Another piecewise function, but you notice it doesn't have a gap in there. Okay? So if I say, what's f of 2? You're going to say, oh, that's negative 4. It's right here at y equals negative 4. Let's go from the left-hand side. What is the left-hand side limit going to give us? It's going to give us, we're coming from the left-hand side. Don't you guys agree the y value is negative 4? Okay, what about from the right-hand side? Well, here we're going this way, right? We're coming from the right-hand side, from the positive side. Well, it's still, again, we're looking at the y value. What's that y value? It's negative 4. It's approaching negative 4. All right, so what's a two-sided limit? Well, negative 4, because these are the same. Okay, and what about the limit as x approaches 3? Well, here's 3 right here. It kind of comes down here a little bit, but 3 is down here. And actually, if I plug a 3 in, right, it's really plugging into this guy. When x approaches 3, I get negative 7. So that's what the answer is to this one. I'm approaching 3. Now, what's f of 3? F of 3 is also negative 7. Okay? So the beauty of this is when you have a hole, you have to realize that the limits don't matter. The right-hand limit is going to be equal to the left-hand limit because the hole doesn't matter. F of something, that matters because I can't be there, but I can approach a hole. Okay? All right, number 6. This is kind of a unusual graph, but basically, if you're not sure what it is, you plot a bunch of points and you kind of figure it out. And this actually turns out, no matter what, if I have 5 over -5, if I put a -5 in there, I get 5 over -5. So it's always positive, and if they're both negative, one goes back to positive and the other's negative. So that's why I get this bottom guy here when it's negative. But if they're both positive, it's +1. The other way, it's -1. All right. Notice I got a hole here, math fans. What's f of 0? I have 2 holes there. It's undefined when it's 0, so what does that mean? It means undefined. Okay, what about f of 2? Well, here's 2 right here, and what is the y value? The y value is 1. Okay, now let's look at as x approaches 0 from the negative side. What's that y value? That y value is -1. What about coming from the positive side? Well, isn't that +1? So what is the two-side limit? Does not exist because they're not equal. Okay? So I know I keep saying it, but I want to say it again. Limits mean you are approaching the value. All right? And f of something means I am there. What's going on at that spot? All right, that's really, really important to understand that. Okay, this last thing, it says use your calculator to evaluate f of x equals y, or y equals, and this big old nasty function for given values, and you're approaching 2. So obviously when it's equal to 2, it's undefined. You know that because of that x minus 2 right there. Okay, and if you plug in values into your graphing calculator, which give it a shot, the main thing you got to remember, math fans, is use some common sense here and lots of parentheses, and you should be in radian mode. Okay, and if you do that, it says round to 6 decimal places. I'm just going to actually put that in here. You guys can do that. And if you don't get these values, then you're not putting enough parentheses in your problem. So 2.149878, and this is 2.094725. And this is 2.040411, and this is 2.033977. Okay, and then the other side, 2.033178, 2.032523, and 1.949401, and 2.2 gives me 1.843656. Okay, so if I said, let's just kind of look at this now. I know these values are very similar, the 1.99 and the 1.999 and 2.0001. If I said, what's f of 2? You guys would say, oh, I'm there. It's undefined. What if I said, what's the limit as x approaches 2 from the negative side? Well, it looks like it's, I know I asked you around to 6 places. Let's just say, let's do 2 places. Would you guys agree it's 2.03, and the limit as x approaches 2 from the positive side, so that was this guy right here, and from the positive side it's 2.03. So what is the limit as x approaches 2? Well, they're the same, so it's 2.03. So it definitely is undefined at that spot right there. But again, that doesn't matter when you're talking about a limit. We're getting closer and closer and closer to that value, but we're not there. So that's why the limit is 2.03 for both left, right, and two-sided limits. But f of 2 is undefined. All right, not too bad. Okay, so the last thing, math fans, I'd like to talk a little bit about endpoints. Okay, so this is endpoints. If I think about it, let's actually just make a quick graph here. Okay, so here's a nice friendly graph. And let's talk about that. How about the limit as x approaches -3? Well, remember, in order to have a two-sided limit, what do you have to know? You have to say, oh, the right side limit is equal to the left side limit. So as x approaches -3, I definitely know what's going on as I go this way. Well, because isn't that getting closer and closer? So let's sort this out here. Limit as x approaches -3 from the positive side, what's the y value? Well, it's equal to 0. What about the limit as x approaches 3 from the negative side? Okay, actually, I don't know that because there is no function over here, right? Okay, so basically, if you don't know that, this does not exist. All right, that's important. Okay, again, you have to know both the left and right side in order to actually have a two-sided limit. They have to be the same. Okay, and obviously you have to know one or the other. So same thing here with limit as x approaches 2. Okay, so don't come up to me and say, well, Mr. Curvis, are you talking about the right hand or left hand? I mean, you guys should look at this right now and say, oh, I'm talking about a two-sided limit because I don't have a plus here, or I don't have a minus here, so which is the left and right hand limit. I don't have those, so that's a two-sided limit, and you guys should say, oh, that doesn't exist because I have no idea what's going on the right hand side. Okay, so that's like I said, that's pretty important to understand that. Even one where if you have a graph like this, f of x equals 1 over x. This is a great graph. Okay, and basically your function kind of looks like this. You have asymptotes here, right? And if I said limit as x approaches 0, well, what can you tell me about that? Okay, you guys should tell me that doesn't exist. Because doesn't this go to positive infinity and doesn't this one go to negative infinity? They're not the same. Doesn't exist. Okay, what if I said the limit as x approaches 0 from the positive side? Well, okay, well, what is that? Well, for the positive side, it's positive infinity. What about from the limit as x approaches 0 from the negative side? Well, there it is, negative side. What's the y value? Remember, we're always looking for y values. That's negative infinity. That's why these are not equal, so that's why the two-sided limit doesn't exist. And what about what's f of x? Or sorry, f of 0? Well, it's also undefined too because it's an asymptote. So it's undefined. So functions can be undefined, and this is important. I'm going to take off for this if you mess that up. Functions can be undefined. Functions don't have does not exist. Okay, you don't say f of 0. What is it? You don't say, oh, it doesn't exist. It's undefined. You got to give me the right terminology. Okay, as opposed to a limit. Limit is never undefined. It doesn't make sense. There's no such thing as an undefined limit. There's a limit that doesn't exist, and that's what you guys have to tell me. All right? All right, that's it for day 1 of limits, and hopefully you guys have a kind of a general understanding of what's going on here. All right? Adios, math fans. Bye-bye.